Always, sometimes, never. A trapezoid is, we're comparing to a parallelogram. Now the definition of parallelogram is two pairs of parallel sides, and a trapezoid's definition is exactly one pair. Well, one can never equal two, so this is never. A rhombus is, and compared to a square. A square means all four sides are congruent and all four angles are congruent. A rhombus is four congruent sides. A rhombus could be a square if it also had four congruent angles, but not all rhombuses have that, so only some of them do. So a rhombus is sometimes a square. A trapezoid, and we're comparing to an isosceles trapezoid. An isosceles trapezoid is a special type of trapezoid where both legs are congruent. Not all trapezoids are going to have congruent legs. Only some of them will, and those some are going to be the ones that become isosceles trapezoids. So this would be sometimes. A quadrilateral is, and compared to a kite. The definition of kite is two pairs of consecutive congruent sides. A quadrilateral just is a polygon with four sides. Well, some polygons with four sides do have two pairs of consecutive congruent sides, but not all of them do. So this would be sometimes. Place each property into the most precise category on the Venn diagram. A. Base angles are congruent. There's only one shape where we even talk about base angles, and that's a trapezoid or the isosceles trapezoid. The isosceles trapezoid is the only one where those base angles are congruent. B. Two pairs of equal adjacent sides. The definition of kite is two pairs of consecutive congruent sides. That meets the definition. However, a rhombus, you may think, also qualifies, but because this statement says two pairs, a rhombus or a square would not work because they have way more than two pairs of equal adjacent sides. C. Diagonals are congruent. There are actually two separate families where the diagonals are congruent. One is the isosceles trapezoid. The more common one we see where diagonals are congruent is the rectangle. Diagonals being congruent is a property of those. D. Two pairs of opposite parallel sides. Two pairs of opposite parallel sides is a property of a parallelogram. Matter of fact, it's the definition. That would be D. One pair of opposite parallel sides. This is the definition of trapezoid. F. Diagonals are perpendicular. In a kite, the diagonals are perpendicular to each other. However, perpendicular diagonals is also a property of a rhombus, so we can put it in both of these. G. Diagonals are congruent. Well, this is exactly the same as C, so everywhere we see a C, we should probably put a G. H. Consecutive angles are supplementary. Consecutive angles being supplementary is a property of parallelograms. In topic 23, we're going to be finding the area of all of these figures. The first thing I want to do for each of these questions is identify what type of shape it is, and then what formula I need to use. For 42, we have a parallelogram. The formula for the parallelogram is area equals base times height. And the golden rule for base and height is they always must be perpendicular. So with each of these questions, the first thing I'm going to do is look for the 90-degree angle. In this case, I see a 90 being made between this and this. Now I want to use the blue as my base because that's the actual side of the parallelogram, and perpendicular to it is my height of 5. So area equals base times height, 10 times 5. 10 times 5 would be 50. And don't forget our units. These are measured in yards, so this would be yards squared. 43. This is a triangle. Area of a triangle is 1/2 base times height. There's my 90-degree angle. So I have my height and my base. So this would be 1/2 times 6 times 2.5, which is 7.5. And my units, yards squared. 44 is a trapezoid. Formula for a trapezoid is 1/2 times the height times base 1 plus base 2. In a trapezoid, the bases are always the parallel sides, which means my height has to be perpendicular to both. And that would be here. 4. Plug everything in. This would be 1/2 times my height of 4, and then 2.1 plus 8.3. Throw those into a calculator and get 20.8 kilometers squared. 45. This is a kite. The formula for the area of a kite is 1/2 diagonal 1 times diagonal 2. In my picture, it's only giving me the length of parts of the diagonals. So to find the length of the entire diagonal, I'm going to have to add those values together. So diagonal 1 is going to be 10 plus 10 for 20, and diagonal 2, 10 plus 20 equals 30. And if I plug those values into my area formula, I would have 1/2 times 20 times 30, or 300, and my units, meters squared. For 46, we have a rhombus. We can tell because all 4 sides are congruent, and the formula for a rhombus is the same as it is for a kite, 1/2 d1 d2. Just like the kite in the last example, I'm going to have to figure out how long the diagonals are because I'm only given parts. Now, because a rhombus is also a parallelogram, and in a parallelogram the diagonals bisect each other, that means if this portion of the diagonal is 3, this one has to be 3 as well. And if this part is 5, this part has to be 5 as well. So d1 would be 3 plus 3, or 6, and d2 would be 5 plus 5, or 10. 1/2 times 6 times 10 would be 30. And my units are feet squared. For 47, we have a triangle, 1/2 base times height. However, in this one, things are a little bit tricky. I'm looking for my right angle, which is here, which gives me this is my base, and this side is my height. In order to figure out the height of this triangle, I'm going to have to use Pythagorean theorem in order to find this missing side. So my hypotenuse is 13. That's got to be C in the Pythagorean theorem. So plugging everything in, I'll call this H. H squared plus 12 squared equals 13 squared. 12 squared would be 144. 13 squared would be 169. And subtract to get the h squared by itself. And then square root. So my height of this triangle has to be 5, which makes sense because this should be the Pythagorean triple, 5, 12, 13. Throw everything into our triangle formula, and we would have 1/2 base times height, 30. And our units are miles squared. On 48, we have a rhombus, 1/2 d1 d2. I'm sorry, not a rhombus, a kite. For this diagonal, I'll have to do the same thing I've done in the other 2 rhombus and kite problems. Add to the 2 parts together. 5 plus 5 would give me d1 is 10. And for the other diagonal, 2 plus 2 is 4. Actually, I'm sorry, this is a rhombus, not a kite. Throw everything into our formula. 1/2, 10 times 4. 420 inches squared. For 49, we have a little bit of a different take on the problem. It's asking me to solve for the height. Now, the height of this parallelogram shouldn't change depending on which base I use. So I can use the fact that a base and a height is going to give me the exact same area as a different base with its corresponding height. So here we've got a perpendicular, so I can use that as my height, and the base that would be perpendicular to it is this bottom section, which is 9. I've also got a 90-degree angle here, so if I wanted to use 6 as my base, the height that goes with 6 would be 12. If I find the area using this base and height, I would do 12 times 6. Because the area of the parallelogram doesn't change depending on which base we use to find its area, that means if I find the area using 9 and h, it's got to be the exact same thing. It has to equal 12 times 6. Well, we can simplify this. 12 times 6 would be 72. And on the other side, 9h. And then, to get h by itself, divide both sides by 9. Number 50. Find the area of the following composite figures. To find the area of each of these composite figures, I'm going to have to break it down into smaller shapes that I can find the area of. For this one, it seems most convenient to divide this into a rectangle and a triangle. For the rectangle, we have a length of 9 and 2 as our base and height, so we would have 9 times 2 for an area of 18. For my triangle, because the entire length of this side of the rectangle is 9, and this top portion that I'm not using is 5, 9 minus 5 will give me a height of 4 for the triangle. To find the bottom side of the triangle, I know the entire length down here is 4, and this section, which I'm not using, is 2, which means that the base of this triangle would be 2. For a triangle, we use 1/2 base times height, so this would be 1/2 times 2 times 4, or 4. To find the final area, we would add these two parts together. 18 plus 4 would be 22, and our units, meters squared. For 51, I'm going to divide this into 2 rectangles. For my top rectangle, I have a base of 2, a height of 5, so its area, 5 times 2, 10. For my rectangle down here, I have a height of 13, but my base is a little bit longer than this 15. To find the base, I need to take the 15 that I know from here and add it on to the 2 that's up there to get the complete distance. Then, base times height, 13 times 17 would be 221. Add my two parts together, and that'll give me a total area of 231, and my units, inches squared. 52. Looks like I'm actually going to have to divide this into 3 shapes. The shape on top in the corner is a square. It has sides of 6 and 6, so its total area would be 36. For my rectangle in the middle, we have a height of 20. However, this 15 went all the way across. So I need to subtract off this part that I'm not using in order to find the total base of that rectangle, which would be 9. 20 times 9 would give me a total area here of 180. Now I need to find the area of the triangle. For the height of the triangle, I know the entire length of the rectangle on the side is 20. There's 5 meters here I'm not using, and another 6 I'm here that I'm not using either. So I need to take 20, the whole length, and subtract off the 5 and the 6. 20 minus 5 minus 6 would be 9. For the base of the triangle, I know the entire bottom length of this thing is 16. At the top, we found that this distance was 9. which means that the corresponding distance down here also has to be 9. 16 minus the 9 I'm not using means that the bottom of this triangle would be 7. The area of a triangle is 1/2 base times height, so we would have 1/2 times 9 times 7, 31.5. Finally, we'd have to add all three of these things together. 36 plus 180 plus 31.5 would give me a total of 247.5, and my units, meters squared.